This is lesson 4.7. First, write down the I can statement that says I can find the inverse of a relation and a linear function. Please pause the video to do so. Then we can look at the definition of an inverse relation. It is the set of ordered pairs obtained by exchanging the x-coordinate with the y-coordinate in each pair of a relation. So if we have 5, 3 is an ordered pair of a relation, then 3, 5 is the inverse of that relation. And they show some more examples of that here in the table, so that if we had -3, -16, its inverse would be -16, -3, and so on through that table. So, in example 1, we are just switching the x-coordinate with the y-coordinate. So if I have -4, 10, now I have -10, 4. If we have 7, -19, now we have -19, 7. Just switching the values from the x position to the y position and from the y position to the x position, as I showed in the next two coordinate pairs there. We had -5, 17, Then we have 17, -5. And we have -3, 11. The inverse would be 11, -3. Same thing if they have it in a table format. Just switching the points. So instead of -4, -13, it's now -13, -4. Instead of -1, -8, the inverse is -8.5, -1. Same thing with 5, 0.5 and 9, 6.5. We're switching the x and y coordinate. Now try the 2 U tries on your own, and we will go over those in class on Monday. To find the inverse of a graph, we are going to first start by picking out 5 points on the graph, such as I highlighted there. I picked 5 points, and I'm going to locate those 5 points coordinates. So each of those coordinates are -3, 2, -1, 0, 1, 2, 1, 2, 2, 3, and 3, 4. Then we're going to flip the x and y's like we just did before. So -2, -3, 0, -1, 2, 1, 3, 2, and 4, 3. Then I plot those 5 points, connect the dots, draw my arrows, and I am done. Do the 2 U tries on your own. Again, we will go over those in class. Now if we look at the next, or the bottom of your page, it says that the graphs from example 2 are graphed on the right with a line of y equals x. Notice that the graph of the inverse of a graph of the original relation is reflected over y equals x, such as in here. I drew that red line a little darker, and then 2, 3 reflected over to become 3, 2. 0, 1 reflected over to become 1, 0. -4, -3 became -3, -4. So for every point x, y on the graph of the original relation, the graph of the inverse will include y, x. A linear relation that is described as a function has an inverse that can generate ordered pairs of an inverse relation. So this inverse relation can be written as f to the -1 power, and it is read as f of x inverse, or the inverse of f of x, either way. Now let's look at how we can do that from an equation. So in an equation, we're going to do the following steps. Please pause and fill in these steps, as we will go over them in a second as I go through each step. The steps are, take the original equation they gave us, and we're going to replace where it says f of x with the letter y. So in example A, I'm about to do this, f of x, I write down the equation, and I replaced it now with y equals 4x minus 8. Step 2 is we need to switch x with y in the equation. So I took x and I put it where y used to be, and I put y where x used to be. Then I need to solve for y again. So I add 8 to both sides in this equation, and I get x plus 8 is going to equal 4y. I still need to get y by itself, so I need to divide by 4 on both sides, leaving me with x over 4 plus 2 equals y. The fourth and final step will be to replace y equals with f inverse of x equals. So same equation that we just solved for was x over 4 plus 2. Now we just take out the y and put in f inverse of x. So if I can go through here quick and show you, here was step 1, here was step 2, all of this was all step 3, and this part was step 4. If you have any questions about the process, just put a star next to it and we can discuss it on Monday. But now I'm going to go through a second example, hoping that this will answer any questions. Again, I write down the original equation they gave me, which was f of x equals negative 1/2 x plus 11. Now I'm going to go to step 1, replace f of x with y equals. So I first copied my equation, 1/2 x, negative 1/2 x plus 11, and then I wrote down my y. Now I need to switch x and y, step 2, with each other in the equation. So x equals negative 1/2 y plus 11. Step 3, I'm going to solve for y. So I need to isolate y, subtract 11 to the other side, and I'm going to get x minus 11 equals a negative 1/2 y. To get rid of that negative 1/2, I have to do an opposite operation. So I can divide by negative 1/2 or multiply by the reciprocal, which is going to be a negative 2. Then I multiply by negative 2 on the left side as well, and I get negative 2x plus 22 is going to equal y. And step 4, I need to replace y equals with f of x inverse, so negative 2x plus 22 is going to equal f of x to the negative 1 of x. Again, I will indicate where I did each step. Here was step 1. Here is step 2. All the way up to here was step 3. And this was finally step 4. I strongly encourage that you write down all of these steps over here. Let me try that again. That color was not very bright. All of these steps over here, so you have them to reference, and try the other 2 examples below this. That is the end of the lesson, the end of the chapter. So if you have any questions, write them down, and we'll go over this on Monday. Have a good weekend.